Hi friends, I am Rajesh. Welcome to my channel, Rajesh's Max Class. Today I am going to take the uniqueness part of the nested intervals property. The uniqueness part of the nested intervals property. Already we had discussed the existence part of the nested intervals property in my previous class. The link of my previous class is there in my description box. So here we are going to learn uniqueness part of the nested intervals property. Clear? The statement is, if in equals closed interval an comma bn, in equals closed interval an comma bn, comma n belongs to capital N belongs to capital N is a nested sequence of closed bounded intervals such that the lengths bn minus an of in satisfy infimum set of all bn minus an such that n belongs to capital N equals 0. Comma then the number psi contained in in for all n belongs to capital N is unique. Okay. The statement is, if in equals closed interval an comma bn, n belongs to capital N, is a nested sequence of closed bounded intervals such that the lengths bn minus an of in satisfy infimum set of all bn minus an such that n belongs to n equals 0. Then the number psi contained in in for all n belongs to n is unique. Clear? Already we have discussed the existence part of the nested intervals property. The statement is proof. The statement of the existence part of the nested intervals property is, if in equals closed interval an comma bn, in equals closed interval an comma bn, n belongs to capital N, is a nested sequence of closed bounded intervals then there exists a number psi. Psi belongs to R such that psi belongs to in for all n belongs to capital. This is the existence part of the nested intervals property. The statement is, if in equals closed interval an comma bn, n belongs to capital N, is a nested sequence of closed bounded intervals, then there exists a number psi belongs to R such that psi belongs to in for all n belongs to n. Clear? Here we want to prove this psi is unique. The additional condition is infimum set of all bn minus an such that n belongs to n equal 0. Here I1 equals closed interval a1 comma b1. What is the length of I1? Suppose this is our real line. So this is I1, closed interval A1 comma B1. This is I1. Okay. What is the length of I1? Length of I1 equals B1 minus A1. Clear? Length of I1 equals B1 minus A1. Clear? Next I2. We have I1 superset I2. I1 contains I2. So this is I2. This is I2. Endpoints are A2, B2. So what is the length of I2? B2 minus A2. Clear? B2 minus A2. Next, I2 contains I3. I2 contains I3. A3, B3. This is I3. What is the length of I3? B3 minus A3, etc. Clear? So the additional point is infimum of this correction. Infimum of this correction equals 0. Clear? Infimum of this correction equals 0. Okay, let us start. So, by the existence part of the nested intervals property, we can write psi belongs to In for all n belongs to capital. Clear? That means there exists a real number psi such that psi belongs to In for all n belongs to capital. So we can write psi belongs to In for all n belongs to capital by the existence part of the nested intervals theorem. Clear? But here we consider there exists another real number. We denote it by eta. Another real number eta such that eta belongs to In for all n belongs to capital. Clear? There exists another real number eta such that eta belongs to In for all n belongs to capital. Clear? At last we will prove psi equals eta. Okay, here we write psi eta belong to In for all n belongs to capital. Clear? Okay. First we take psi belongs to In for all n belongs to n. Psi belongs to In for all n belongs to capital. Clear? Okay. Implies psi belongs to what is In? Here In equals closed interval an, bn. So we can write psi belongs to closed interval an, bn for all n belongs to capital. Clear? Implies psi belongs to closed interval an, bn means an is less than or is equal to. Psi belongs to closed interval an, bn means psi lies between an and bn. Clear? That means an is less than or is equal to psi. N is less than or is equal to psi, and psi is less than or is equal to bn for all n belongs to capital. Clear? That means n is less than or is equal to psi, which is less than or is equal to bn for all n belongs to capital. Clear? Okay. So here we write an is less than or is equal to psi, which is less than or is equal to bn. An is less than or is equal to bn. An is less than or is equal to psi, and psi is less than or is equal to bn for all n belongs to n. So, okay. Next we take eta belongs to In for all n belongs to n. Eta belongs to In for all n belongs to n. Clear? Eta belongs to In for all n belongs to n. Clear? Okay. Similarly, we can write eta belongs to what is In? In equals closed interval an, bn. Eta belongs to closed interval an, bn for all n belongs to capital. For all n belongs to capital. Clear? That means eta lies between an and bn. So we can write n is less than or is equal to eta. N is less than or is equal to eta, which is less than or is equal to bn for for all n belongs to capital. Clear? N is less than or equal to eta, which is less than or equal to Bn for all n belongs to capital. So here we can, okay, n is less than or equal to eta, which is less than or equal to Bn for all n belongs to n belongs to capital. Okay. Next, we multiply each term in this inequality by -1. Clear? We multiply each term in this inequality by -1. So this becomes minus an greater than or is equal to minus eta greater than or is equal to minus bn for all n belongs to capital. Clear? Multiplying each term in this inequality by -1, then this becomes minus an is greater than or is equal to minus eta is greater than or is equal to minus bn for all n belongs to capital. The inequality will be reversed. Okay, so we can write minus bn is less than or is equal to minus eta is less than or is equal to minus an for all n belongs to capital. Clear? So here we can write minus bn is less than or is equal to minus eta is less than or is equal to minus an for all n belongs to capital. Clear? Minus bn is less than or is equal to minus eta is less than or is equal to minus an for all n belongs to n. Clear? Next, adding these inequalities, we get an minus bn. That means an plus minus bn. An minus bn is less than or is equal to psi plus minus eta. That means psi minus eta less than or is equal to bn plus minus an. That means bn minus an. For all n belongs to capital. Clear? Okay. Instead of this term, we write minus of bn minus a. Clear? Because minus into bn minus bn minus into minus an. Clear? So we can write minus of bn minus an, which is less than or is equal to psi minus eta. Psi minus eta is less than or is equal to bn minus an for all n belongs to capital. Clear? It is the same as the form minus c less than or is equal to minus c less than or is equal to a less than or is equal to c. Clear? Minus c less than or is equal to a less than or is equal to c. We have minus c less than or is equal to a less than or is equal to c implies and implied by modulus a less than or is equal to c. Here c is a non-negative real number. If c is a non-negative real number, if c greater than or is equal to 0, then we have minus c is less than or is equal to a is less than or is equal to c implies and implied by modulus a is less than or is equal to c. Clear? So it is the same as the form minus c less than or is equal to a less than or is equal to c. Clear? So we can write modulus a less than or is equal to c. Clear? What is a? A is psi minus eta. Clear? So modulus a means modulus psi minus eta. Modulus a less than or is equal to. Modulus a is less than or is equal to. Clear? Modulus a is less than or is equal to c. What is c? Here c is bn minus a. So modulus a is less than or is equal to bn minus a. Clear? Bn minus a. Also, we know that modulus of any real number is greater than or equal to 0. Clear? Modulus of any real number is non-negative. So we can write 0 is less than or is equal to modulus psi minus eta is less than or is equal to bn minus an for all n belongs to capital. Clear? Okay. So here we can write 0 less than or is equal to 0 less than or is equal to modulus psi minus eta less than or is equal to bn minus an for all n belongs to capital N. Clear? Okay. also we have infimum set of all bn minus an such that n belongs to n equals 0. So we can write infimum set of all bn minus an such that n belongs to capital N equal 0. Clear? That means consider the connection. Set of all bn minus an such that n belongs to n. Clear? Consider this connection. What is the infimum of this connection? 0 is the infimum. 0 is the infimum. Clear? 0 is the infimum of this connection. Okay. Next, epsilon greater than 0 is an arbitrary real number. Epsilon greater than 0 is an arbitrary real number. That means for any epsilon greater than 0, we can say that epsilon is not a lower bound. Epsilon is not a lower bound. Epsilon is not a lower bound of this correction. That means the set of all bn minus an such that n belongs to capital N. Epsilon is not a lower bound of this correction. Set of all bn minus an such that n belongs to capital N. What is the reason? Here, 0 is the infimum of this correction. 0 is the infimum of this correction. That means 0 is the greatest lower bound of this correction. Clear? 0 is the infimum of this correction means 0 is the greatest lower bound of this correction. That means any number greater than 0 is not a lower bound of this correction. Clear? Any number greater than 0 is not a lower bound of this correction. Here epsilon is greater than 0. Epsilon is greater than 0. So epsilon is not a lower bound. Epsilon is not a lower bound of this correction because epsilon is greater than 0. Here 0 is the greatest lower bound of this correction. Any number greater than 0 is not a lower bound of this correction. Here epsilon is greater than 0, so epsilon is not a lower bound of this correction. That means we cannot say that every element in this correction is greater than or equal to epsilon. Clear? Because epsilon is not a lower bound of this correction. That means we can find at least one element in this correction which is less than epsilon. We denote it by bm minus am. Bm minus am. Here m belongs to capital M. That means we can write there exists bm minus am in this correction such that bm minus am is less than epsilon. Clear? Bm minus am is less than epsilon. Here small m belongs to capital M. Capital M means the set of natural numbers. So here we can write bm minus am less than epsilon. Epsilon. Here m belongs to capital M. Clear? Bm minus am is less than epsilon. Okay. Next. Here we have 0 is less than or equal to modulus psi minus eta, which is less than or equal to bn minus an for all n belongs to capital N. Clear? Put n equals m in this inequality. Put n equals small m in this inequality. So this becomes 0 is less than or equal to modulus psi minus eta less than or equal to bm minus am. Clear? Bm minus am. But bm minus am is less than epsilon. Bm minus am is less than epsilon. Bm minus am is less than epsilon. Here epsilon is an arbitrary for any epsilon greater than 0. For any epsilon greater than 0. Clear? Okay. So we get 0 is less than or equal to modulus psi minus eta, which is less than or equal to bm minus am. Bm minus am is less than epsilon for any epsilon greater than 0. Then we can write 0 is less than or equal to modulus psi minus eta, which is less than epsilon for any epsilon greater than 0. Clear? Okay. Next we apply a result in real analysis. That means if 0 is less than or equal to a, which is less than epsilon for any epsilon greater than 0, for any epsilon greater than 0, then a equals 0. Clear? Next we will apply this result. If 0 is less than or is equal to a, which is less than epsilon for any epsilon greater than 0, then a equals 0. Clear? it is the same as the form 0 is less than or is equal to a is less than epsilon. Clear? Here a equals modulus psi minus eta. Clear? Psi minus eta. After applying this result, we have a equals 0. That means what is a? Here a is modulus psi minus eta. That means we can write modulus psi minus eta equals 0. Clear? Psi minus eta equals 0, which implies psi minus eta equals 0. That means psi equals eta. Clear? Psi equals eta. Clear? That means psi is unique. Clear? That means if in equals closed interval an comma bn and belongs to n is a nested sequence of closed bounded intervals such that the lengths bn minus an of in satisfy infimum set of bn minus an such that n belongs to n equals 0, then the number psi contained in in for all n belongs to n is unique. Clear? So we proved this result. Clear? So I hope you have enjoyed my class. Thank you.